Oh, hi there. Remember to like, subscribe, and share for all the greatest content money can buy. Let's rock. Hello, and welcome to another episode of Game Over, where we discuss interesting topics while playing some badass video games. My name is Ace, and I will be your host today. I'm joined by a couple of friends of mine. Want to say hello, Susie?
Hi, Ace. Hi, everyone. How are you?
Wood?
Hello.
Atrix?
Hello. How's it going?
Guys? We have a great game for you guys today. Horizon Zero Dawn. This game has been out for some time, yet it's never managed to lose its value as one of the greatest open world games in recent history. The story follows the tale of a young girl named Aloy, who finds herself born in a harsh world based off of the Mesozoic Era, where you are being trained from an early age to fight off against the massive mech dinosaurs that are inhabiting the land that you call home. The whole theme and idea of the game is based off an era that seems almost lost to us due to how long it actually transpired. Thanks to the work of several influential paleontologists, though, we were able to articulate research based off of fossils along with the ever-changing geological state of our planet to derive the interesting and rather magnificent nature of the old world and its inhabitants. I'm currently joined by a paleontology major that will help us reveal more of the state of the world 250 million years ago. So, Atrix, you want to take over?
Yeah, sure.
Can you let us know how it began in the first place? How did it all start? 250 million years ago. How did the dinosaurs come to be, and what was it called, that period when it all began? Was it an extinction of whatever came before, or how exactly did it happen?
Well, if you want to start from the beginning, the first thing that happened to set off the Mesozoic Era, first and foremost, was the Great Dying. That happened 252 million years ago. So that concluded the end of another era in time, and that's the Paleozoic. And so it went from the Paleozoic to the Mesozoic. Okay. Now, the first few things that happened in that period of time during the mass extinction was that a lot of species died off. We're talking like 90% of marine life, which is a big deal. Biodiversity, amount of species that's around, it's like a little empty, So the world has to recover.
Interesting.
That's the first thing that pretty much sets it all off.
Do we know what caused this mass extinction? And was it mostly aquatic animals during that time before the Mesozoic?
The land got affected as well. Yeah. The land was like a landscape of ash, volcanoes.
Okay.
The entire world was sort of not having a great time.
I see. But we're not fully aware of what caused that extinction, are we? Do we know if it was a meteor? Do you know if it was the same reason behind the Mesozoic Era extinction, or was it?
It was a lot of stuff. Leading up to that time, the climate was changing.
I see.
Permian was a time that the climate was very dry, very arid, and that continued, and a lot of tectonic activity happened, and a lot of volcanoes started going off, and this was the time where Pangea was also forming. So a lot of this insane geological activity is happening. The world is kind of in turmoil, and a lot of animals die in the process. But some survive. Land animals survive. Some sea life survives. It's not like the entire world sort of like died, but it came really close. Earth has had a lot of mass extinctions in its history, so this one came close to basically killing off most of life. I think the number for overall is 70%, around there.
Interesting.
It's
Is it safe to say that the least complex of the creatures during mass extinctions those are the ones that usually survive. So the one-celled organisms or the small-scale organisms are usually the ones that make it out of these things.
Well, if we go with the fossil record, the surviving forms, they basically fill in everything, and that leads to a lot of evolution. And that led to basically the foundation for what we call actually modern ecosystems. A lot of familiar forms appeared during the Triassic, and some of them may have looked weird, but they would develop into a lot of the things we would see in the Mesozoic. If we skip a little in the Triassic to at least like late, the beginning of the late Triassic, you start to see a little earlier than that maybe, like the first actual dinosaurs. They didn't appear in the early portion of the Triassic, for the most part. Archosaurs, reptiles in the water, like sea reptiles, they're around. Pterosaurs were also developing, so there's that too during the Triassic.
Interesting. Did the Triassic come first?
Yeah.
Okay.
Yeah, it's the first of the three portions of the Mesozoic.
So let me get this straight. The Mesozoic started, and then within the Mesozoic era, the Triassic was the first period to start during that era. And
yes, it was the first of three.
That's when which creatures exactly started to emerge? Did we have dinosaurs during that time?
We 100% have dinosaurs from the Triassic. It's just they don't come in the immediate beginning of the Triassic. You have to skip a little down to like the middle of it, and definitely later half. The later half is when they start to diversify a little more. You start to see forms that found like whole like dinosaur families.
Interesting.
And the main types that you see in like the museums, like the big ones, like the sauropods.
So Atrix, what survived and eventually caused evolution towards dinosaurs? So what evolved towards becoming dinosaurs after the first period and during the beginning of the Mesozoic era?
Archosaurs.
These
are basically the cousins of the dinosaurs. A good example of one, we found one in North America. It's called Postosuchus. If anyone has watched Walking with Dinosaurs, everyone knows what I'm talking about. It's a big crocodile-looking thing that walked on its heels. It was upright. So it looked kind of like a dinosaur, but at the same time, it looked kind of like a crocodile and had these scoots on its back, too.
Interesting.
So there would be animals like that. That's an archosaur. And there's like anatomical differences. You can identify a dinosaur from archosaur. If you had the bones right in front of a paleontologist, they'd be like, yeah, this is this and this is this. So we know these things existed during the Triassic, and eventually they transitioned to dinosaurs, and dinosaurs flourished when the archosaurs pretty much died out. So the dinosaurs kind of started flourishing, doing their own thing, and they beat out the archosaurs, and that kind of kick-started the next era of the Mesozoic.
I see. So the very first creatures that sort of kick-started this whole thing were, in fact, aquatic animals. They're the ones that managed to survive the very first mass extinction.
Not quite. Okay. They didn't give rise to those. No. Those are sea reptiles. These are like later on in the Triassic. You see nothosaurs and ichthyosaurs. Those are not dinosaurs. Dinosaurs. It's hard describing the exact origin because it's a little bit of a blur. But there's the idea that the main idea of what we know. Somewhere along the line, there's a closest common ancestor that represents a certain thing. Certain few key characteristics we call dinosaurs, and they came from archosaurs. They came later down the line, somewhere in that point. Where the archosaurs came from, they came from reptiles that survived, like terrestrial reptiles, not aquatic ones. That's the word I'm looking for, terrestrial. These were animals on the land, for the most part, hunting like small prey, and they eventually developed into something, and then dinosaurs kind of diverged off that something, and that something we assume is archosaurs, pretty much.
I see, but we don't exactly know the origin of those creatures, do we? Because,
we have an idea.
Oh, okay.
And the idea, we know practically where they're supposed to. It's a lot of phylogenetics, a lot of
Okay.
complicated relations from one animal to another. So,
I see.
and it's how you map out what dinosaurs are related to what.
I see.
We know that the sauropods were first carnivores, and we know that dinosaurs are ancestral to carnivory. They first started off as meat eaters and then transitioned off to the plant eaters at some point. You know that.
I think it would be considered as crossbreeding, right? You're bringing in all these different biological constructs and you're taking something out of each and together, mixing them together and then creating something entirely new.
Well,
Yeah.
metabolism was a difference between the archosaurs and the dinosaurs. That was a thing within their evolution they had to attain to really separate themselves. They had to be more active, let's say.
Okay.
And we know dinosaurs can be a mix between warm-blooded and cold-blooded. We know this for a fact. It's actually those kind of key differences that kind of set them apart from reptiles and from those lineages.
Yeah,
So-
I had no idea actually. That's quite interesting. So I had always thought that they're all lizards, so they would all be essentially cold-blooded.
Dinosaurs are essentially birds.
Really interesting. So it is crossbreeding.
Well, it's a reproduction is an aspect of it, but it's not one of the major things behind it. Evolution is the major driving behind.
Yeah.
It's the major driver behind most of life itself. There's minor things like the climate, the environment that pressures into those changes sometimes, allowing for them to achieve adaptations that they gotta have to, survive and not go extinct. So it's always the driver of most of these kinds of situations. Reproduction does play an aspect in that.
I
So
see.
I don't know if that exactly answered your question.
No,
What we did.
it makes it understood a little better. It's just, like you said, there is sort of a little involvement in crossbreeding, and then eventually whatever organism was created from that was able to evolve into a flying, breathing creature of its own, or the other forms of dinosaurs that we've grown to love in our younger age. Speaking of, by the way, before we actually move on to the Jurassic period, Woodplank is actually the youngest of us, and I believe that you had always wondered what it takes to become a paleontologist, and you're actually most excited about this topic today, weren't you, Wood?
Correct. Also, evolution isn't only crossbreeding. Evolution also comes from mutations and natural selection.
Natural selection is what makes the other animals go extinct, yes. And the mutation aspect is something that has always existed for all we know.
Yeah.
Like unique alleles and unique things in certain people. Yeah, so you're right on the money with that, kid. Yeah.
Oh, there you have it. I think that the flying ones were the velociraptors, correct?
Well,
So
the
define-
flying ones were birds, but birds evolved from stuff like Microraptor, which was another raptor, but smaller than Velociraptor.
Yeah.
Oh, okay. And then
Yeah.
eventually
I just
that's how
wanted
they
to-
evolved into velociraptors. Gotcha. What was that, Atrix?
I just wanted to mention he has some animals in the Discord chat posted from the Triassic. Posasaurus is one of them.
Oh, okay. Well, they look fairly early on, except for the big one, the one in the middle.
That's the Plateosaurus, yeah. That Plateosaurus was what later became the giant sauropods you see at the end of the Mesozoic, yes.
Yeah.
Plateosaurus, it was an upright animal, walked on its back feet, unlike you later see in bigger sauropods, but basically these were precursors to those animals. A lot of people just call them prosauropods. Usually I just call them sauropodomorphs because that's the scientific term, let's say. And basically, Plateosaurus, it lived in the Triassic for the most part, and
It did.
fed on leafy
Interesting.
greens, as we all know, and it had really unique upper posture to it. It had these claws, and people have made paleo art of them, pulling down like trees, and and browsing for just leafy greens and all that. Yeah.
So throughout the almost 200 million years of the Mesozoic era, there have been dinosaurs that have stayed alive for that long. Like they evolved and just stayed where they are throughout those 200 million years, like the Paleosaurs, right? Because they first appeared during the Triassic period, right? And then they were there at the end. I had assumed that during the Triassic period, it was always like the smaller creatures, right?
Yes, I meant to say that the family Plateosaurus is a part of continued to the end of the Cretaceous. Prosauropods didn't last that long because they finally learned to walk on their front feet. So, since they were mainly upright animals, still eating a lot, they were getting a lot of mass, alright? They're herbivores.
Yeah.
They eat a lot, and they grow a lot, and so basically they had to find a way to distribute all that weight. So they had to go quadrupedal, and they started evolving the long necks, which is kind of what we see in the Jurassic. And then that continues into the Cretaceous, pretty much. So
they were classified as families, and those families continued evolving throughout the periods of the Mesozoic era, and eventually they became the huge monstrous creatures during the Cretaceous era. Interesting.
Yeah.
Moving on from the Triassic, I assume that we actually have a time lapse of what had actually happened during the Triassic before we jump into the Jurassic.
Yeah, so essentially, the beginning of the Triassic starts with obviously the Great Dying, transitions, and the Earth cools off, and we get our formations of the first modern ecosystems, so it begins to look like ecosystems for us today. Mm-hmm. And slowly at that time, we have all these different animals developing, and archosaurs appeared in that time, and later on at the end of the Triassic, dinosaurs diverged from archosaurs, and this is at the same time sea reptiles were first taking their origin, marine reptiles, and along with flying reptiles, which are the pterosaurs. Mm-hmm. And so that really set things up for the Jurassic.
Mm-hmm.
I remember there was a Triassic extinction, I just didn't know what it was about.
There was Triassic Jurassic boundary extinction. It's interesting. What essentially happened was it killed off basically a lot of the archosaurs, and it killed off a lot of different animals from that Triassic time. That those old animals like the archosaurs, they disappeared along with other different kinds, and this extinction event wiped out basically a good amount of those terrestrial animals, and that was another key move for dinosaurs to evolve. And that ended up in early theropods and early sauropods transitioning to, well, that quadrupedal lifestyle, eating all those leafy greens all the time and growing very big. Also became a theme with the carnivores throughout that time in the Jurassic.
Mm-hmm. That's how it happened. After we transition to the Jurassic period, that's when carnivores start becoming a lot more common, correct? Or is that just sort of a Hollywood blockbuster kind of setting?
To explain that, I guess, all dinosaurs are ancestrally carnivorous, and they eventually diverged into a plant-based diet. So you had your basic herbivores and your basic carnivores, and during this time they were small, and they had to basically survive a lot of different events that came their way, and eventually they started becoming big. In the early Jurassic, which is actually an animal that I actually hold near and dear to my heart, and Woodplank has a picture of it. It's called Dilophosaurus. Very famous dinosaur from Jurassic Park. It was a lot bigger, 23-foot-long theropod. Had a big crest on its head with powerful arms, and it was like one of the first true theropods. One of the first big guys on the plain searching for food.
Mm-hmm. It's definitely enlightening to know that, because I always assumed that they were the smallest type of dinosaurs, but you're saying they were 23 feet?
20 to 23 feet long, yeah. And wow. Coelophysis, which was a much earlier animal, that was a carnivore. Famous late Triassic theropod from North America, just like Dilophosaurus. They might have overlapped in time, and yeah, they did. They did in Arizona, but I digress. Basically, Coelophysis was much smaller than Dilophosaurus, and that lived in the Triassic, and eventually, again, when those carnivores finally got their chance to shine, and well, they did. They started eating more, started progressing more, developing new features, and you can see that in Dinosaurs, 100%.
During the Jurassic period, all of the dinosaurs that first evolved were carnivorous, and then eventually
in the Triassic,
Okay. So by the beginning of the Jurassic period, the ones that survived the extinction were both, or was it still more in favor of the carnivorous type of dinosaurs?
Yeah, dinosaurs successfully evaded the Jurassic extinction. They were fine for the most part. But that did end up leaving, the world empty, and I don't really have numbers for how much were around right after, but there's a lot of bias in the fossil record. Like, some things get preserved, some don't, so because the Earth preserves like 1% of the entire fossil record, what we know of. So it's a slight glance into what we're really looking at. But I guess what I'm saying is they progressed eventually, and they started really diversifying in the Jurassic versus the Triassic, which came before.
I guess they had to, right? Like, since
they had to,
a lot of them were extinct, they had to. Herbivores started coming out, essentially, in order for them to survive. They started eating plants. So it was just like a natural...
because
it was a natural way that things progressed. Gotcha.
The natural progression, yeah. You have the leftovers of what was before filling in the niches. Niches are these roles in the environment.
Mm-hmm.
Your niche is your role in your environment. You eat this thing. You do this thing.
Yeah.
It was what makes you who you are, and you have all these features that make you unique. And
what I find interesting is that the Diplodocus, am I saying that right?
Yes.
Dude, I'm probably butchering it. But yeah.
You're not doing too bad.
What's odd is that they were the biggest dinosaurs, yet they were still herbivores. I find that strange, since you would assume that carnivores would be the ones that would be ruling the Earth during the time, but it seems that the biggest dinosaurs during the time weren't even eating meat. They were just herbivores. They were eating plants.
Well, the thing is, you know how the food pyramid exists?
Yeah.
Well, there's an energy pyramid where the plants get 100% of the energy goes to plants, and then only 10% of the energy that goes to the plants goes to the herbivores. Oh. And only 10% to the carnivores, and 10%, 10%, 10%. So, basically, if a carnivore were the biggest, it would die out because it wouldn't have enough food to sustain itself. Which is why herbivores generally stayed the largest.
So during that time, Atrix, you want to tell me that geologically speaking, the planet was actually well cultivated, despite the ridiculous number of extinctions that keep happening, and the world's heat wave and all of the reasons why the dinosaurs kept dying out. You want to tell me that plants were still able to survive during these harsh times?
Grass didn't even exist until the end, roughly around the Cretaceous, and nothing happened pretty much after the Triassic-Jurassic boundary event, where the world kind of went to like a sliver of what made the Great Dying Bad basically happen. Volcanic eruptions and all of that stuff. It threw off, obviously, the world, but they were able to develop in. The world progressed naturally afterwards, but there were no major events that really touched the dinosaurs from that point on until the meteor hit, and other things were happening at that time as well. And naturally, there always will be plant eaters more than meat eaters for the most part. Bigger too, because of basically what Woodplank said, and the whole metabolism thing. They're eating a lot more. They have much better access to food too, and these meat eaters have to waste a lot of energy just to get sometimes one kill, and you see that in the wild all the time. So it's another good way of putting it.
Exactly. But so that doesn't really give me a picture of how the environment was during that time, because this whole time I'm assuming it's a barren land. I guess after millions of years passed, then it would make sense that plants start emerging. But even then, wasn't land mostly compressed, or was it separated over the body of water on the planet?
During this time, there was Pangea. Everything on land lived, basically. The big supercontinent. This was present during the Triassic, and it only started to get broken up during the Jurassic. And it made a lot of different ecosystems and a lot of different habitats. And during this time, too, plants were coming back, yeah. There's a place in Arizona called Petrified Forest. It has remnants of trees that were once in the Triassic. So we know the world was healthy. And we see that, too, in the Jurassic. You see a lot of plant life, too, like ginkgo leaves, ferns. Plants we see today, they were in the Jurassic. So, yeah.
So it was all one continent during the time. So water wasn't as spread out as it is now. And so I would assume...
there was a big sea.
As if the whole continent was an island, right?
Essentially, and then everything else was just the open water. You probably had, like, sparse land here and there, and...
Yeah.
It didn't look like our world today. It was, so one big continent.
I'm assuming that the herbivores existed on the outskirts of the island, right? Closer to the water.
No. It depends on what data we have, but that's naturally not the case. They were mostly, like, inland, because they were feeding on cycads, that were things that are close to the ground. They had, some of them probably fed on trees. I mean, some were maybe more coastal. I mean, floodplains were a thing. Those were things back in the Jurassic, so it depends on what data we have, but that's likely not the case. Not most of them were near water. I don't think so, at least. Because we don't really have that kind of data, and naturally that's not something that would happen.
Yeah.
The Jurassic is also when feathers started to appear, am I correct?
Yeah.
They're less like the feathers we see today, and they're more like the baby bird feathers, the fluffy ones. What are they called? Downy feathers. They were more like downy feathers and sharp quills that were used for intimidation and display.
Yeah, you're right on the money for the most part. Feathers are assumed to be something ancestral to almost all dinosaurs because of their relation to birds, because we even have a classification to avian dinosaurs and non-avian dinosaurs. Avian dinosaurs are what we all call birds, and the non-avian ones are the ones that died 66 million years ago. But to answer your question, yeah, feathers appear in the Jurassic. Archaeopteryx is an example. Calindrodromeus, which is an ornithopod, meaning it's a small herbivore that ran around and ate plants pretty much, it had feathers. And other animals had quills that he also mentioned. Epidexipteryx.
Yeah, that one.
Yeah, it makes me feel a lot better now. Even our pro-paleontologist is having problems. How am I supposed to get it right?
They have complicated genus names, but when you get the pronunciation down, it's easy to say. So Epidexipteryx. It was a very weird animal.
Yeah.
It was a weird animal, and I don't know why they name them certain words. They want them to mean something.
I guess.
They want, most importantly, for them to mean something, because that's the genus name. It's a scientific name, like Dilophosaurus, two-crested lizard.
Yeah.
Diplodocus, it's hollow something. Stegosaurus, roofed lizard. Like, I mean, they have to mean something to the scientists, of course, that study them.
There was another thing. The first ever dinosaur discovered actually came from the Jurassic. Megalosaurus.
That is right. Yes. Megalosaurus. Discovered by what would become to be the first few founding figures in paleontology. Sir Richard Owen first coined the word dinosaur in the 1800s. Our history of the science isn't that too old compared to the actual science we study. But Epidexipteryx, we were talking about that. It was herbivorous. It ate on insects. Scientists think it ate on insects. They think it's insectivorous and herbivorous, so it wasn't like a scary meat eater. It looks freaky, I know, but... But that's all for show, because, again, during this time, you have a lot of biodiversity. They want to keep their species alive. They want to diversify. better biodiversity, better habitat. So you get these weird dinosaurs sometimes in the fossil record. Stegosaurus, Kentrosaurus, those are actually two animals on the Jurassic image. They're both in the same family, and they have these thagomizers, and Stegosaurus is a thagomizer, Kentrosaurus not so much. Kentrosaurus has these big spines coming out of its back. Looks like a wicked display, and essentially that's what it's for, yeah.
I'd always wondered if the reason why they looked so intimidating was it because they were usually aggressive towards one another? Was there ever any
social
peace
behavior?
with the dinosaurs?
Yeah. There've been ideas. A good one that I can recall: Stegosaurus and Camptosaurus. They footprints of both animals have been found together, and we can tell sort of they had a relationship going on. It's been reconstructed actually in a documentary, Planet Dinosaur, which isn't a bad one. Basically, they have Stegosauruses going for the low browsing stuff because that was their niche, that was their job. And then the Camptosaurus would have what they want, take what was left behind, since they're the small animals. And they would be on lookout because they had an acute sense of sight and hearing, and it'd be like meerkats going out on the outpost, seeing if there's a big Allosaurus coming their way, and the Stegosaurus would be basically more towards in the center, or sometimes even with these dinosaurs, most likely. They could chill around each other, for the most part, the plant eaters. The meat eaters will bite each other.
Friendly dinosaurs. That did exist, actually. So Barney is not a myth.
Well, Barney's a T-Rex, and they weren't so nice to each other.
Oh, okay. So on the other side of the spectrum, there were actually dinosaurs that only cared about killing one another.
No. They always go for the plant eaters, yeah. I mean, Tyrannosaurus always loved eating Montosaurus. We know that from the fossil record. It was primarily what they ate, which they're later in the Cretaceous. But Montosaurus would be these plant eaters called hadrosaurs that would develop eventually from what we know as Camptosaurus, which hung out around the Stegosauruses in the Jurassic. But what would happen is, and what we would see in the fossil record, is a lot of Tyrannosaur infighting. Like a good amount of it, we see it sometimes. There's a Tyrannosaur in the Cretaceous before Tyrannosaurus called the Splitosaurus, frightful lizard, and it had some infighting. There would be tooth marks and puncture wounds in the bones, and it's interesting for the most part to see that, I guess. So
when you say infighting, it's within its own species, right? Like
Tyrannosaur v Tyrannosaur, yeah. It would happen from time to time. The term for it that we scientists call intraspecies fighting.
Okay.
So in the species, they're fighting one another for mates, for dominance, just all that kind of stuff that you would mainly need to have as a carnivore, a big one.
The marine reptiles, what were they like?
They were cool. Liopleurodon is a cool one. It's actually one that you have on the image here. Liopleurodon ferox. It was a big pliosaur. It was a little bigger than me, let's say. I'm 5'11 and a half. It was a little bit bigger than me. And it would basically do what it's doing in the picture, actually. That's what it does. Hunts ammonites, small invertebrates it can fit into its mouth, big ones like that. Probably other plesiosaurs, which are the long-necked ones, which also stuck to fish, but yeah, that one's a cool marine reptile. There's also the ichthyosaurs. A lot of them have been discovered in Europe.
So were those the only aquatic dinosaurs, I'm assuming?
They're not dinosaurs. Okay. Marine reptiles.
So there weren't actual sea dinosaurs. That did not exist.
Aquatic dinosaurs existed for a brief moment of time. We know the family Spinosauridae.
Should we wait to talk about Spinosauridae in the Cretaceous?
Yeah, because Spinosaurus is an interesting animal.
But that only happens after the Cretaceous period.
Yeah.
Okay.
Yeah, but these marine reptiles are in no relation anywhere pretty much near dinosaurs. Yeah. They're not really they're marine reptiles. they didn't really diverge from the same lineage as the dinosaurs, pterosaurs, and archosaurs. They weren't much of a part of that. They developed their own way, pretty much.
I have this odd question, and it's not scientific in any way, but why the interest in the Jurassic period of all periods? I mean, I would assume the Cretaceous would probably have the most amount of dinosaurs and creatures that existed since it's the end of the era's lifetime. But yeah, you never see the Cretaceous Park on TV. It's always Jurassic Park, or everybody's always fascinated with the Jurassic period and theme parks and stuff like that. Like, why is that the most common period? Is there a reason behind that? Is there a reason why it's more popular than the other two periods?
I think it was because there was more biodiversity.
A lot of it had to do with you just saw dinosaurs everywhere. Woodplank was basically on the money with that. Yeah, because you saw dinosaurs everywhere pretty much. And also Jurassic Park just made that a big deal. I mean, it came out in 1994. I'm wearing a Jurassic Park t-shirt right now, so I should know this. But I'm going to say 1994, 1992, somewhere around there.
Yeah.
And that made it a big deal to everyone who just knew about dinosaurs. Like, oh, Jurassic Park. It was something they could relate to. Yeah. And a lot of the biodiversity you see comes later in the Cretaceous. The Cretaceous has a much more extensive record than the Jurassic. But at the same time, we have a lot of material from the Jurassic as well. Plus, yeah, Jurassic rolls off the tongue better. Cretaceous, Jurassic. One last thought. The other thing with the Jurassic, too, is just, yeah, there's a lot of material. Like, you can go to, like, Colorado, Utah, and all these different places in the American West, and there'd be mass assemblages of dinosaur bones. It's a lost world, yeah. Essentially what Jurassic Park makes us think, yeah.
I guess it makes sense. And I think it really is because Jurassic just rolls off the tongue better. That's probably the only reason, to be honest with you.
I think that's why they chose the name to Jurassic Park.
Yeah. It's
like Cretaceous Park. Doesn't sound right.
It's interesting though, because you said that there was an extinction that happened between the Triassic and Jurassic periods, but you make it seem as if that wasn't the case when the Cretaceous period starts. So what actually marked the beginning of the Cretaceous period?
The world started to break up a lot more. You start to see the silhouettes, more or less, of what you would see to become North America and South America. Basically, that would be the first thing. The animals also started to change, too. Sauropods got a lot bigger. Jurassic carnivores are different from Cretaceous carnivores. Like, you have Allosaurus in the Jurassic, but then you would see Carcharodontosaurus in the Cretaceous. They're both distantly related, so the animals changed as the world changed around them. That led to a lot of biodiversity. The first angiosperms, the flowers you see today, they appeared in the Cretaceous. Grass appeared in the Cretaceous, which is an interesting thing to think about, too.
So I guess during the Cretaceous period is when the Plateosaurus, the ones that first emerged during the Triassic period, now that they have access to all those plants and grass, that's when they became known as the biggest dinosaurs to ever roam the planet, right?
Yeah, they took off in the Cretaceous. The biggest of which is Patagotitan. One is in my museum, and it can barely fit in the room it's made for. And it can grow up to a little over a blue whale. So it was 100 plus feet. 109 feet, I think, is the estimate.
It's also debated whether Argentinosaurus or Paleotitan was the largest.
Yeah, but we do know Argentinosaurus is, at the moment, the absolute biggest and also heaviest. The estimates for Patagotitan got a little set back from like 115 to 109. And that gave kind of the lead back to Argentinosaurus, which is the heaviest of the dinosaurs. So that's cool too, yeah. There is another image with more Cretaceous themed now, so
I'm just enjoying looking at all the new creatures and the coral reef.
Coral reefs were a thing, yeah. Coral reefs were around. We pretty much know that because, well, limestone sedimentary rock is preserved. So for the most part, we know reefs existed here and there because they go through the carbon cycle. Calcium carbonate creates limestone. That's geology term, sorry. But the sea at question, there was a big inland sea. I'm actually reading a book all about it. It's called the Western Interior Seaway. And there are two animals from the Western Interior Seaway during the Cretaceous. It was a little near the end. It wasn't when... It was almost dried up when the asteroid hit. But two animals from that sea were Mosasaurus and Archelon. And it's in the Discord chat amongst the Cretaceous pictures. Archelon was a big sea turtle. You know Crush from Finding Nemo?
Yeah.
Like a really big... Yeah, like a big turtle. They had their own family and everything. And Archelon also wasn't the only one. This unique family of marine sea turtles. There were also Protostega, which is a much more well-known Western Interior Seaway marine turtle. There are others of its kind, and Mosasaurus were the marine reptiles. Mosasaurus, we actually know, is closely related to monitor lizards, and that sort of family of reptiles. 40 plus feet in size. Really, really big marine animals that would provide food for the ecosystem itself while it's like feeding. So the scraps of what it was feeding on, which would be virtually anything, by the way, because it was so big. Sometimes even other mosasaurs. Those are two examples from the Western Interior Seaway. During, a little before that, there was Microraptor, which Woodplank is going to actually talk about. I'll hand it off to him here.
Okay, so Microraptor. Microraptor was in the family of, well, raptors. Stuff like Velociraptor, Utahraptor, and of course, Microraptor. Microraptor was a in-between stage between dinosaurs and birds. It could glide. It could not fly. It did not have really powered flight, but it could glide. And that's how it managed to maneuver so well. It hunted small animals such as lizards, baby dinosaurs, and anything else really small it could find. Microraptor was also one of the, well, main things that caused the smaller pterosaurs to become less prevalent. At least that's from what I know. The birds evolving made the smaller, like the size of birds, dimorphodon-like creatures that lived would go extinct due to birds and other means.
So the Microraptors were actually carnivorous, right? They
Correct.
Yeah, they were always on the hunt, and during that time, did a lot of the carnivorous dinosaurs from the Jurassic period actually make it through? So were T-Rexes still around? Because I mean, so far it's still my favorite dinosaur. I mean, it's always been my favorite dinosaur.
Anything larger than a wolf was most likely killed during the Cretaceous Cenozoic extinction. The
KPG mass extinction.
KPG mass extinction mostly killed anything larger than a wolf that couldn't really hibernate or do anything to last a long time, which is why birds made it out, and something like the giant Quetzalcoatlus and Hatzegopteryx didn't make it out. Quetzalcoatlus and Hatzegopteryx were large pterosaurs, which hunted small dinosaurs and potentially some sea life.
That extinction that you just mentioned, you call it the KPG?
KPG mass extinction. It stands for Cretaceous Paleogene, and that's a boundary in the geological record. It's like a black stripe, a really dark layer, and then from there it transitions to the Paleocene, which is the beginning of the Cenozoic.
Okay, so that is the end of the Mesozoic Era, as we know it, right? So that KPG is the meteor that struck the Earth. Okay.
And Tyrannosaurus lived around that, a little before that, yeah.
I noticed that a lot of the creatures during the Cretaceous period, like the ones that you mentioned, Atrix, the turtles and the ones that are in the picture, like that rhino-looking one, the Torosaurus.
Torosaurus.
They look similar to creatures that we know of nowadays. You know what I mean? Like they are. Some of them still do exist. Am I correct in assuming that?
Well, birds are avian dinosaurs. So, yes, they still exist among us. But Torosaurus,
I think it means like rhinos are very similar to like a Torosaurus.
Yeah. Exactly. And the turtles, the Archelon, they look like the old turtles, the bigger ones in the sea. I'm not sure if there's like a correct term for them.
Leatherback sea turtles.
Tortoise. Oh, yeah. Leatherback sea turtles. So they still exist to this day. Are there more creatures like those?
I was about to bring one up.
Yeah.
Sarcosuchus. Sarcosuchus is a crocodilian, which means it's related to alligators, crocodiles, and ganals. Ganals are just... I don't know how to explain it. It's like a crocodile with a really long snout. Really thin, long snout. And Sarcosuchus was part of that group. While it did not live, many of its close cousins and close genuses did. They were smaller, but the thing about them is they could hibernate. Reptiles don't have something like a reptile. A crocodilian doesn't have to eat as much as a lion or a dinosaur, because dinosaurs were mostly warm-blooded by the Cretaceous period, while Sarcosuchus and other crocodilians are cold-blooded, meaning they can hibernate for longer and require less food.
Interesting.
Yeah, they can last longer than dinosaurs. Think of it like there would be a period they would just eat. They would have enough to hibernate, last through the dry season. River comes back and Sarcosuchus survives. Unfortunately, during the time in the Cretaceous when Sarcosuchus was around and this would happen, the droughts eventually got worse and worse and worse. And eventually, a certain point in time in the Cretaceous, the climate changed and the entire process just gone. It was it dried up, and they ended up going extinct probably because of those changes in climate. So there is that, yeah.
Oh, and there was one dinosaur that you wanted to talk about, Atrix. Spinosaurus.
Oh, yes, let's talk about Spinosaurus. Alright, well, Spinosaurus is weird. It's one of my favorite dinosaurs, along with Dilophosaurus. Spinosaurus is a very controversial dinosaur. People think it swam around in the rivers as an aquatic pursuit predator, and that's a theory some people are sort of on with. However, the anatomy points to something very different. It most likely was more like a grizzly bear, and it had specific adaptations for something like this, similar to a crocodile, which gives it its iconic appearance. And basically these straight, conical teeth, much like a crocodile, would be dipped into the water or above water. It didn't really matter because they had pressure sensors, allegedly, in their snout. Basically, because of these pits within their snouts, it's assumed that they're pressure sensors that, even with their eyes closed, they'll still hit the fish. And they had neck muscles that would basically have it where they could dive down their heads really fast to catch the fish out of the rivers of northern Africa, which is where they were at the time of the Cretaceous. Spinosaurs are weird. They're the aquatic dinosaurs I was sort of alluding to earlier.
I think I actually found myself a new favorite dinosaur, man. That sounds like the most debilitating of all dinosaurs, the way you're explaining it.
It was the biggest carnivorous one, too.
Yeah.
So
it actually looks kind of like an aquatic animal than a dinosaur as far as dinosaurs go, right? As far as land dinosaurs go.
Yeah, Spinosaurs.
That weird fin on its back.
Oh yeah, the spines. Yeah.
So those are its spines. Okay.
Yeah. It's neural spines. Yeah.
And
there are a few ideas.
That's how they can navigate. That they're actually able to use that as a way to navigate through the water, right? It helps them?
Not exactly.
Oh, okay.
You see, to explain, I guess, the biology behind it, basically, what they found in the chemistry of its bones were that they were thick. They can swim around better, and along with, what was it? The reduced hind legs, and basically, the sail wouldn't help it swim. And we know this because it's just really heavy. It most likely was like a hump. Like, you know how camels have humps? They have like nutrients and fats in there.
Yeah.
Spinosaurus might have had the same thing. It was either that or it was a big sail, but for the most part, people think it's just like a really big bump or really thick sail.
Yeah.
And
exactly. That's why I thought.
And the reason why
move underwater.
The tail was the other thing, which people thought it could help move underwater. It was kind of like a newt's tail. Like, you know, salamanders, and they have like these cool like ribbon tails.
Yeah.
Yeah, it kind of had that, but at the same time, it still wouldn't really help. People think it was a display structure. There's two scientists, really good ones, that made a paper this year going over the entire anatomy, because this is such a big deal amongst scientists. Because we don't know what it was. They have to have a definitive answer. And because, well, every other Spinosaur pretty much like lived like a bear, they had big claws, and they had to last like arid areas where these rivers were when the seasons changed, and that's the idea that we're sticking with. But some people think it was a active pursuit predator.
The electroreception, which is what the bumps do.
Yeah.
Like you said, it's hard to explain how it works, but I feel like the best thing close to it would be radar. You don't need to look at the fish to see that it's there. You can just look on a little panel. But with a Spinosaurus, it's like that panel is like inside of their brain, so they can always see that.
Essentially, what they're doing with the pressure sensors, the pressure sensors would detect these signals of pressure changes in the water, and you know what changes pressure in the water? A mass, a fish, and they can just snap their fingers and boom, they caught a giant sawfish, giant coelacanth, stuff like that. So it was like a dinosaur fisherman, so to speak.
I could see why they're your favorite, man. So actually, I have a question. Now, despite them being your favorite, and despite each and every one of us sort of being biased towards a certain dinosaur, but you know how they say the lion is the king of the jungle, right? Which dinosaur could you claim to be the king of the Mesozoic era?
The king of the Mesozoic era.
Yeah.
Are we talking about popularity or...
Nah, the strongest, the coolest, like the one that is majestic, as the lion would be in the jungle.
I would say T-Rex, because mainly that's the one people go with when they first think Cretaceous. When someone thinks of the Cretaceous, the first thing they think of is T-Rex. And it's a large predator that relies on bite, and it doesn't have, well, the best of arms. But it's what people think of because, well, it was popularized.
I feel like it wasn't just that. I feel like they were also the strongest, like in terms of how fast they were and how strong their bite is, right? Because their legs seem to be a lot stronger and bigger than most dinosaurs. And they seem to be like more agile and smarter. At least that's what I've heard.
Well, it depends what paper you're looking at. Papers have put the T-Rex max speed from 12 miles per hour to like 42 miles per hour.
Oof.
So it's pretty hard to gauge what the actual thing is when there's so many contradicting the other ones. But it's generally accepted that it's around the same speed as like most other large carnivores at the time, which was, I think, less than 20 miles per hour. The way people thought it would hunt things would be to ambush them. And you gotta remember, Hadrosaurs were like the fastest large dinosaur at this time. And stuff like Parasaurolophus could only run 25 miles per hour.
Mm-hmm.
Generally, some like a Parasaurolophus or other hadrosaurs weren't that fast compared to modern animals. And T-Rex had to catch them by surprise in order to catch them. T-Rex couldn't just run up to them, like roaring at them like you see in movies. It couldn't just roar at them and then try and bite them. They would be long gone by then. So I would think if a hadrosaur could outrun it, it has to be less speedy than the hadrosaur.
For the most part, he's right.
They were crafty, right? So they would actually ambush them, meaning that they were smarter than most other dinosaurs in terms of hunters or carnivorous dinosaurs.
Well, people equate the intelligence of a T-Rex to a modern-day chicken. So they weren't that intelligent, but compared to the herbivores, they were pretty intelligent. Because the herbivores of the time were even dumber than the carnivores. They didn't have much to do.
So the T-Rex wasn't the smartest of all the creatures during that time? Because, I mean, their skulls look huge, right? So I would assume they must at least harbor something in there, right?
Yeah, intelligence is generally accepted as brain-to-body ratio. So that's why a sauropod is generally accepted to be dumber than, like, a human. Even though it's much bigger and its skull is bigger and stuff, it's dumber.
I'm not even comparing, because that's a whole other thing. I'm just comparing the dinosaurs of the time. So I'm comparing T-Rex with all the other dinosaurs during the Mesozoic era. Is it? Yeah, it was
of like average intelligence, I want to say.
So it's not the smartest of all the dinosaurs, you don't think?
I think that would mostly be like the birds and the raptors. Because birds did exist in the Mesozoic. Birds evolved during the Mesozoic and lived in the Mesozoic.
Yeah.
And another thing was that the smartest things of the time were most likely not the dinosaurs, from what I've heard. It was the mammals. Although mammals were small, rat-like creatures, in order to survive, they had to be pretty smart and crafty. So, like, not running out when they just wanted to. They had some intelligence.
That I didn't even know. So, Atrix, are you telling me there were mammals here at the time?
Yeah. Yeah, no, mammals existed throughout a lot of Earth's history.
And
we're part of one of the...
ever since the Triassic, or did they later...
Yeah.
Yeah, they evolved in the Triassic.
Oh.
Yeah,
they evolved in the Triassic, but they were mostly smaller, like mouse-like creatures. Some of them got to be the size of a dog, but mammals evolved before proto-mammals.
Yeah.
Were like an in-between between, I think it was reptiles and mammals, and stuff like the Gorgosaurus, and other large mammal-like creatures that weren't mammals. They were an in-between phase. And one of those was a very rat-like creature that managed to get to the Triassic. And after the Triassic, it diverged into more mammal-like creatures until it was just a mammal.
Yeah. To kind of simplify, basically, in the Permian, which was that time before the Triassic, there were proto-mammals, so wood plank, for the most part, is on the money, basically. Since they're proto-mammals, they don't really look like mammals, but they have what would become mammals later on. A basic design that a lot of them have today, a lot of terrestrial ones mainly. And
sort of like the genetic code that eventually came to be.
Yeah, but they were still a part of that archaic, ancient lineage that was reptiles. Because reptiles only developed fairly recently. The reptiles only appeared in the era right before the Permian, which is the Carboniferous. Amphibians were starting to be big around then, and reptiles developed around there then.
And mammals didn't exist during that time. Mammals only came after the amphibians.
Very recent Yeah, after the Permian, they actually appeared in the Triassic, and they were in these small forms, like what Woodplank was stating. They would still be like ancient forms, but they slowly became what we would call like placental mammals, which are ones with placentas, which is almost entirely all mammals have for reproduction.
Oh, and I just remembered what the proto-mammals were named. Synapsids. Synapsids was the name of the proto-mammals.
Yeah, it's the term for there's a certain hole in your skull that you can feel. You can do it yourself. I don't know exactly how, but you have to feel around in your temple, and there's a depression, and that's your. I think the term is actually synapse. It's an opening of some kind.
I think synapses exist all over your brain, though, right? It's sort of like
this
trigger mechanisms. Or are you talking about a different synapse?
It's probably a different term, but essentially you feel around on your skull, and there's a depression, and that represents a hole in your skull, and that hole in your skull makes you more related to Dimetrodon, which is like an early synapsid from that Permian time to like any dinosaur practically. So it's something ancestral to a lot of mammals, this one opening in the skull. So
how did all of this end up in a museum, man? Like, why did it all go? What happened there? What happened in the end? What's this KPG eradication that happened, and why is it called like that?
KPG stands for Cretaceous Paleogene, which is it's a layer of rock that represents a time when the Earth was just not in a good mood. Kind of like how the Great Dying played out. This was serious, but the Great Dying nearly killed the world, pretty much. This extinction event was serious, but eventually mammals bounced back, and that's what defined the Cenozoic. But basically, what happened was dinosaurs started to slightly decline during this period. Smaller forms are being much more favored. And that eventually led to a slight decline. And during this slight decline at the end of the Cretaceous, which was happening amongst the dinosaurs, a meteor smashed into the Gulf of Mexico and left a pretty big mark. It upset the entire planet. Volcanoes went off again. Suffocating air, ash, it just coated the world, and it killed off every non-avian dinosaur.
There was a heat wave.
Yeah.
And that's what covered the entire world and caused all these gases to emerge and isolated the Earth from the sun as well. Like, the Earth wasn't getting any sunlight for quite some time.
It was also a meteor.
It's funny that happened after the extinction event. It's a bit odd because I thought what you were referring to, the KPG extinction, I thought that was a result of the meteor. So you're saying the extinction began before the meteor struck the Earth?
The event of the dinosaurs declining before the meteor hit isn't entirely related. It shows that they were decreasing in this time a little before the actual extinction happened, which is when the meteor hit. And basically killed every non-avian dinosaur. And the meteor that smashed into the Gulf of Mexico, first there was an initial shockwave. Granite, pure rock, like bended when this thing smashed into the Earth. And that caused a chain reaction amongst the entire Earth because it was upset because a giant space rock just hit it.
Exactly.
And the volcanoes go off. And it throws off a lot of our environments that these dinosaurs lived in. And then, the sun couldn't reach into the atmosphere because it was plagued by a lot of just bad material. And then when the dinosaurs inhaled the material, it like suffocates them too. So, and this also suffocates the plants. And this suffocates eventually the sauropods, and well, the carnivores can't live off that for so long because, well, this is it's not a crazy long period of time, the event actually happening. It wasn't for a crazy long time, this whole chaotic event with all these dinosaurs dying. It eventually ended.
Well, birds and mammals were two of the few creatures that made it out. And the thing about mammals is they diversified very rapidly after the KPG mass extinction. Mainly because most of the niches, the thing we talked about earlier, were unfilled. And since they were unfilled, it left room for stuff like horses and mice and stuff like that to become a thing. And the thing about horses of the time was they didn't look like horses. They looked more like a weird dog-sheep hybrid than a horse. They had hooves, but it was like 5-toed hooves. A hoof on each of 5 toes, basically. And they were very small. Smaller than a golden retriever. And these were some of the first, larger creatures which came out of there. And by large, I mean just bigger than a mouse. But one of the many things that managed to come out was birds. Birds evolved from stuff like the microraptor we discussed earlier. And the thing about birds is the flight aspect of them. The flight aspect allowed them to get food better and faster. It allowed them to fly long distances, and it allowed them to find rare resources, stuff like nuts and meat, and those type of things after the KPG, which allowed them to survive better. Now, if flight was such an important thing, then why did stuff like Hatzegopteryx and other pterosaurs die out? Most of it is generally accepted that the pterosaurs of the time were large. Most, if not all, pterosaurs during the KPG mass extinction, at least right before it and during it, were rather large. At least the height of like a child or larger, like 5 foot.
So it is as Atrix was saying that mostly the smaller animals were the ones that survived. Not just the KPG, but actually the meteor that struck the Earth. And I think it could have also had something to do with the environment, right? Because I believe that is something that we've completely ignored here. When there's a huge crater which is the size of the Gulf of Mexico hits the Earth, for a fact that the land is no longer going to be the same. I'm assuming, geologically speaking, our planet came to be closer to how it is now after that meteor, right?
Yeah, the world wasn't quite the same.
Thanks, Woody. You have a really bright future ahead of you as a paleontologist, and you could tell how passionate you are about it, so just keep it up.
I totally agree with Ace.
Oh,
great job tonight.
Thank you for letting me be here, and I will see you next time.